So I just wanted to give you an update on the accessibility map I was working on for the city of Raytown, and this is a school project for a class in GIS I'm taking. And so what we're looking at here is the city of Raytown, the border, the outline of the city, which you can download off of the ArcGIS online, and you clip it down to the outline of the city itself, and then you can do a view extent clip under data frame properties right here where you clip to shape, and you choose that specific shape, the outline of Raytown in this instance, and it chooses to only show what's inside of that shape. So what we've got here are bus lines, bus stops. Do I have bus stops turned on? Bus stops, park and rides, bike lanes and bike trails, which are in purple, and then of course sidewalks, which are pale green. And I digitized the sidewalks layer, which means I had to go in and draw it point for point. I also had to digitize the public spaces, which are like parks and things. I was able to download off of, it's called MSDIS, and they have spatial data and stuff like that. I downloaded the outlines of building footprints, and so that's right here, building footprints, and all the different types. All it has is their type, their usage type. It doesn't have any other information, and I think it's because it take it right out of OpenStreetMap. I also was able to download all the address points in the entire city, which is a lot. But using those two things, it basically allowed me to only have to digitize the sidewalks. So all the information I needed was available to me to make an accessibility map. So from there, I thought to myself, well, what do I want to display? I want to display pedestrian. This includes, walkers and bikers, pedestrian accessibility, and just where are areas where it's high, like where does it have good pedestrian accessibility to get, to where you want to go within the city, and where is it low. And so the first thing I needed to do was figure out sidewalk coverage. And there are a couple ways that I thought of doing that. And one is I selected the streets that have sidewalks, and I made a layer out of only that. So here are only streets are being shown that have sidewalks. And that's sort of helpful, but it doesn't really give true sidewalk coverage, because just showing streets that have sidewalks doesn't really show like the area that they serve, the coverage of the sidewalks themselves. So what I then did was I took the address points and I created a 150-foot buffer around every single address point. And then I selected, using the select by location, I selected these circles basically that intersect with sidewalks. And then I made a new layer from the selection, and I called that 150 foot address point sidewalk coverage. And so if I turn on the streets and if I turn on the sidewalks, you'll see that this sort of gives you a service area for each sidewalk. It shows the coverage area of the sidewalk. And this is helpful to give an idea of residences and where it's actually being used. Like if I was to look right here, it's not probably being used because there are no address points there. But at the same time, there's another way to do it where instead of making the buffer basically for the sidewalks off of the address points, I could just make it off of the sidewalk itself. And so here I did an 100-foot buffer because 150 is pretty significant. And if we look down here at actual blocks, it covers all of the houses on that side of the street without going over to the other side of the street as well. So it seemed like 100 was good here, whereas 150 was good for the points. And I just think that's just the matter of how the points were not necessarily evenly spaced. Whoever digitized them, didn't digitize them very, they didn't use a very standard method of digitizing. They're kind of all over the place. And so in order to catch the sidewalks with that search, the selection search I did, where I needed them to intersect, I had to make the buffer a little bit bigger. So I did that, and then I also added bufferings for bus stop, and I thought 1 mile buffer is probably good for a bus stop. And then I also added bufferings for a park and ride. The only thing about this is these aren't quite as helpful because they only supply service to the bus line, which doesn't stop in Raytown. It only stops in Kansas City and in outlying areas. So you're only going to get on that if you're trying to go outside of the city. So when doing accessibility analysis for the city of Raytown, it's not very helpful because it's service that is going outside of the city. It's not staying within the city. So if there were more bus stops in the city, I think this would be more practical. So I'll turn those off, and the last one was public spaces buffer, and this shows the 1 mile radius around all parks to show what neighborhoods have proximity to parks. The problem with this is it doesn't really show overlap. Now you can do overlap and show overlapping areas, but the bufferings are really, they're drawing a shape, and they don't really show scales of coverage or degrees of coverage. They just show like a straight, this is the area that it covers. This is 1 mile radius basically. They don't really show actual coverage. So something we learned in class how to do was to do Euclidean distance, and what it does is these buffer rings here are basically shapes. When you do Euclidean distance, it actually draws an image basically. They call it a raster, and it can display, there's in GIS we look at basically problems or like habits or demographics, statistics basically. Anything that you would want to map, you look at it as either discrete or diffuse. And if it's discrete, the point, lines, and polygons vectors are the best way to depict it on a map. But if it's diffuse, you have to use a raster, like an image, just because it's not as uniform. Like if there are no uniform shapes, you can't click on a shape and say, oh, that's this. Each cell has its own individual value, kind of like an Excel spreadsheet. And so it's difficult to do actual spatial analysis, like if you wanted to look at a network and say, oh, this place leads to that place and connects with this place. You can't do that with a raster, you have to do that with a vector. With a raster, you can look at it and see actual coverage. It shows areas better, regions and zones and scales and gradients. And so for this to actually find accessibility, the Euclidean distance is helpful. What you do is you open Euclidean Distance under Arc Toolbox, and it's under Spatial Analyst Tools, which you have to enable under your extensions. You have to check the box next to Spatial Analyst Tools under Extensions, and it's under Distance, and you just click Euclidean Direction. You want to do that one first, because if you don't, then the distance is going to be weird. When you do Euclidean Direction, though, it's going to pop up a page like this, and you will get, you want to use your source feature. So for instance, I started with sidewalks. I'll just click on sidewalks, and then I also want to save the Euclidean direction and the Euclidean distance. So two files it's going to create. You name each one and you save it to your geodatabase. You can also determine the output size, cell size, which the default is usually fine. But you may want to make that smaller or higher. It just depends on the resolution you're looking for. For the city, though, I think this resolution is fine. And you just run that, and it's going to create Euclidean distance for a sidewalks layer. So what we will get, the output, is going to look like this. This is Euclidean direction. And basically, from each side of the feature that you're looking at, it's going to measure the direction. North, south, east, west, northeast, southeast, and this is, what you're seeing. This isn't what you're going to show. This is for the purpose of drawing your Euclidean distance. You have to have this file in order for the other one to work properly. So then what we get is the actual Euclidean distance. And what this does is each cell, whatever resolution you chose for your cell size, it assigns a value as in meters away, or whatever unit you chose. It could have been feet or miles, but it's going to say for this it's meters. Like each cell has a value of distance, meters in distance away from whatever the feature was that you chose. In this case it's sidewalks. And so let's turn off this buffer. So what you see here are the sidewalks right here in light green, and the shaded areas, darker shaded areas, are further away from the sidewalk, and higher shaded areas are closer to the sidewalk. And what I did for this was I used, you go down to properties, and you go to display, or Symbiology, and you classify it using quantile, at least for sidewalks, because the sidewalk coverage is very, very exponential. The closer you get to a sidewalk, the exponentially more coverage you're getting. And the same goes for the further away from a sidewalk, you get exponentially less coverage you're getting. If you live on another street, you're not going to walk over to another street's sidewalk just to use it. So this was a good classification system to use for sidewalks. So we get a map, and it's basically, coverage. It shows sidewalk coverage. These areas have good coverage, this area has good coverage, this area has poor coverage, this area has poor coverage, and so it gives a rough idea of coverage. I just do the same thing for public spaces, which are parks, and it's displaying in different colors, and I did the same thing for commercial areas, which are businesses, excluding churches and schools. And so this shows commercial areas, and the purpose of the commercial areas is to show what areas of the city have to go further to get to, like shopping, dining, health services, government services. The purpose of the public spaces is to show what areas have access to a public recreational space, which is key in zoning. But if we combine all three, well, before we do that, I need to mention that this Euclidean distance, it will only draw from the edge of whatever features it is that you're selecting. So like right here, this green area is Mount Olivet Cemetery. It originally only draws the grade, this gradient, the color gradient, what you see here, all the colors, from the edge of this, and so the bottom half of my map is going to be white with no gradient. So what I had to do, and what you will probably always have to do, because I'm only showing the extent of the edge of Raytown, but my map can go further out beyond the sides. I go in, I turn on editor, like I showed you in that other video, and I edit the public spaces layer, and I add 4 extra tiny little shapes at the 4 corners of what I'm looking at, and it extends the gradient area, the analysis area, out so that it draws everything and not just the edge of this little, the area where the public spaces are. It actually draws the entire area. And I had to do that for all 3, public spaces and commercial areas. Didn't have to do it for sidewalks. And that's because the sidewalks, for the most part, intersect with the edge of the shape of the area of Raytown anyway. And so for all of these, I then have 3 rasters. And they give a good idea of individual coverage for commercial areas, sidewalks, and public spaces. But what I want to do is I want to create an accessibility map for pedestrian accessibility, which is including cyclists. And I need to add a caveat that all of the streets that have bike paths have sidewalks. So that's why I didn't make a separate one for bike lanes, because all of the roads that have bike lanes have sidewalks. But what I did for this is I go under, it's still under Spatial Analyst Tools, and it's under Math. Well, Math or Map Algebra. You can do it one of 2 ways. The easiest way is to use Raster Calculator, where you select your 3 rasters, which are sidewalk distance, public spaces distance, and commercial areas distance, and you add them together, and you click OK. You make sure you export it to the right geodatabase, and it will merge them all into one. Sometimes the raster calculator doesn't work, and you'll have to use the plus tool, where you just add one file, one feature class, one raster to another. So in this instance, I would add like sidewalk distance to public spaces distance, and then I would do whatever the output of those 2 was to the last one. And it's just like adding, if you've got to add 3, but you can only add 2 at a time, you add the first 2, then you add the output of those 2 with the last one, and you're going to have all 3 in the end. The output in this case I called 3-factor accessibility, and it just applies, it adds all of them together. You can do it as a minus or divide, depending, each is going to be a little bit different, but in this case it just added them together and shows this straight up arithmetic, just straight up areas with the greatest and least value. So areas that have good sidewalk coverage, good public space coverage, and good commercial coverage are going to be these dark areas. Areas that have poor in all 3 are going to be these blue areas, and the lighter areas. And so this gives an idea of overall accessibility. And so what we've done here is we've created an accessibility map that shows actual coverage. You can look at it and see, oh, I live here in this little pocket, which means if I look at scale, which I have, or my legend, which I haven't labeled yet, you can see that this represents, in this instance, I guess the dark areas are actually low value areas, which makes sense because we're measuring distance from these places. Areas that have greater distance are going to be having lower coverage, and so the areas with low distance have better coverage because you're closer to your commercial areas, your public spaces, and your sidewalks. And so here we can just look at it, and without having to do any research, without having to open up any of the data or anything, we can see where the coverage is. And so it's a much more visual map. But for this, I think 3 is simple enough. It shows straight up coverage, and you get a good idea of areas that have poor coverage, and that the city should probably add some bike lanes and sidewalks to, and maybe a park, like right here or something, because there are no parks in this area, and there are none down here either, and areas that, you know, are okay without having any sidewalks for now, if they're going to prioritize. Areas like right here, they're close to parks, they have sidewalks, but they're having, you know, that really high value that shows far distance from all three factors that we added, mainly because they're really far away from the commercial areas. And so it shows that maybe they should consider either putting in better infrastructure here, like sidewalks, and maybe a public place or something, or that maybe they should consider putting in a small, if they're going to look at truly mixed use and try and make smart growth, which is part of planning, but if they were going to do that, then they might consider adding a small commercial strip down here. I know that there is in Kansas City a commercial strip along the edge, so this might not actually be as low as it says it is. But for the most part, if we just look at Raytown, if, you know, the city wants people to stay in Raytown in order to be able to meet their needs and have full, I guess, activity, like all of the needs that they should have, be able to stay within the city. I'm not saying that people are going to, but the city should have that as their goal, to provide full coverage for all of its residents, so that people aren't having to leave the city to go do stuff. Then they might want to look at adding, you know, some commercial down in this area. But I do know that down in Kansas City, which stretches around the south and along the west of Raytown, there are some commercial areas here. So people who live in South Raytown can just go into Kansas City to do what they need. But for the most part, there isn't like a massive commercial district like there is along 350 or along Blue Ridge Boulevard in Raytown cutoff. So overall, I think that this is, you know, it's limited to the extent that it's not super detailed. The sidewalks are pretty detailed because I digitized them, but as far as the buildings go, and as far as like actually address points and, you know, seeing the actual statistics and the data, this isn't a very detailed map, but it's good as a thematic map to show a specific concept, which is accessibility for the city of Raytown.